So we'll start with the problem statement. So assuming that we are working as an analyst for a pizza delivery chain, so they have collected some interesting characteristics of customers who have purchased their pizza. So now the marketing team is planning for a campaign to release a newly launched pizza. So here we are provided a data set with some features regarding each customer. So based on that, we need to segment the customers and give offers accordingly. So going to how we segment the customers into clusters. So we use the k-means algorithm. So here, if you see what are the various features that are provided is customer ID, gender, age, annual income in thousands of dollars, and spending score, which is a rating between 1 to 100. Right. So here, what we see why in our plots, we see that the females are the highest spenders across all categories. Right. The next thing is spending category versus the age. So here we see that the age group 20 to 40 are the highest spenders. And if we plot an annual income with the spending score, we see that the points are sort of clustered. Here, this graph shows the highest distribution of age. So here we see that people between 20 to 40 are the highest in numbers. Here we follow the elbow method to identify the appropriate number of clusters. So here you see after 5, there is a plateau. So this is where this forms sort of an elbow. So that is where we choose 5 as the number of clusters. So when we choose 5 as the number of clusters, so here we see that there are 5 clusters which is forming. So here we see annual income versus spending score. So the 5 clusters, so the way how we name it is, this cluster in red is low income and low spending scores, or in other words, low income and low spenders. While the ones in greens are high income and low spenders. The one in blue here, you can see that. So they are medium income and medium spenders. And the one in violet are low income, high spenders. And the last one in orange is high income and high spenders. Now we use this clustering information to come up with certain marketing offers. So here we have primary customers and our potential customers. Primary customers are the ones who are higher spenders, right? Higher spender as in the spending score is relatively higher. So here from the data set, we observe that the spending score is relatively higher than the income. So that means that they are probably using a credit card. So in high spenders, we have two categories again. One is the low income, the other one is the high income. That is low income, high spenders, high income, and high spenders. So here, since we are hypothesizing that they use a credit card, so we offer discount on credit cards so that we retain these customers. The next one are the potential customers whom we are trying to bring to the primary customers. So the first one is the low spenders. In low spenders as well, we have two different categories, low income and the high income. So to the low income categories, what we do is we give an offer of 10% on the membership plus a referral code which has a validity. And for the high income, since they can afford the membership, so here we are giving a higher discount on the membership. And medium spenders, according to the data, we have seen that most of the medium spenders are in the age group 40 to 60. So from we have a hypothesis that is people who are above 40 tend to go to pizza shops lesser as they are conscious about their health. So since if we have the data for this customer, that means that they are either coming up with their office or maybe they're coming up with family. So for those kind of customers, we offer discount on bulk orders such as buy two, get 10% off, buy three, get 15% off. So this is the marketing strategy. Coming to the architecture of the pipeline. So here we have the Kafka broker, and then we have the Kafka stream application. So Kafka broker houses all the topics that is required for the streaming pipeline. So first thing what we do is the CSV that we have with the customer data, we load it into the database. And from the database, we pull it to Kafka through Kafka Connect. So this connect the connector. So connector is basically a tool which pulls data from the database to the topic. The next thing is we have a Python producer which writes to this topic called customer location. That is, it writes random locations for each customer, right? So once we have this customer location, we read that data from the topic, the streams application, and we do a filtering. Once we do a filtering, then we'll join it with the pizza customers. So once we join with the pizza customers, we come with the enriched customer information, as in all the customer details would be joined with the location the customer is in. So this we are writing to another topic so that there can be other consumers which can consume with this and may do some analysis. The next thing is we consume from this customer enriched, and then we generate an offer discount based on the marketing strategy that I just described a while before, and then write to customer offers. And from customer offers is where the consumer application will pull and then send, say, an SMS to the customer, right? If I go to the data flow, it is similar. So first from customer location, we consume the data, join it with pizza customers to get pizza customer enriched, and we write that data to the database. And also we use that for offer generation. So for this offer generation, we already have this cluster information and the marketing offer. With that, we write to this customer offers, and then we write it to this consumer application. The location generation is as follows. So what we do is we consider the mall to be in certain location, and we are interested in, say, around 500 meters around the mall. So we divide it in a grid system. So here we see the ones which are in green, that is the customer is in the area of interest. And here customer, if the customer is in the gray region, then the customer is not in the area of interest. So we filter out this in the streaming pipeline. So once we do that, what we do is we generate a deterministic location generation, right? So here we have, we number it 1 to 8, and then based on certain probabilities, they move from region 1 to region 2. Region 2, they can stay in the same region, they can go inside the mall, or they can go to this outer region, or they can also go to the next state that is there. So we use this logic for location generation. The streaming pipeline is written in Java. So here we see that the topology is written. So we build a table using this pizza customers. Then we consume from the customer location, filter out the customers which are not in the area of interest. We do a stream table join and enrich the data. This enriched data is written to database and also to a topic customer enriched. And then from customer enriched, what we do is we set the offer. So how we are getting this offer is based on the marketing strategy that I just described a while before. So let's start the demo. So first, I will be starting the Confluent Kafka. Confluent Kafka comes up with a set of features like Zookeeper and Kafka, schema registry, Kafka Connect, Kafka REST. So here we are using Zookeeper, Kafka, and Kafka Connect. So Zookeeper is used to maintain all the metadata regarding the topics, and Kafka houses the topic, the data themselves, and the data to the broker mapping, right? That is maintained in Zookeeper. And Kafka Connect is used to connect the database and pull in the data to a topic. Let's wait for the Kafka services to be up. 。 . 。  . 。 . 。 . . . . . . . . . . . . . . . . . . . . . 。 . . . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 . 。  . So the Kafka services are up now. So we can check it from the control center, Kafka control center. So here you see that there is one broker with partitions and certain topics. Going to the topic screen, we can see what are the topics that is there. So here we have three different topics that needs to be created. The first one is customer location. This topic has the details of the customer ID and the region that the customer is in. Then we have customer enriched, has the enriched information of the customer, that is all the customer attributes along with the region. And the last one is customer offers, has the offer details along with the enriched customer detail. So here now we have three topics. The next thing is to connect the database to Kafka. Before we connect, let me just show. So here if you see pizza customers, so this data is loaded into the database. Now what we'll be doing is we'll be using a connector to pull in that data to Kafka. So here I specify what is my connection URL. So here you see that the database name is restaurants and my table name is pizza customers. So what happens is once the connector is up and running, on the table name, the same as the table name, we will be having a topic. I'll just show that. So now we see that the status is running, right? Now when we go and check the topics, so here we see there is a new topic called pizza underscore customers. We can check the messages as well. What were the messages starting from say offset 0? So here you see, right? So we have the same information as a JSON string: customer ID, gender, age, annual income, spending score. Now that we have all the topics and the data in place, let us run the pipeline. So this is a Spring Boot application which has Kafka streams. Now you see that the status is changed to running. Now we will be able to produce to this particular. So for the demo purpose, I'll be showing just one customer and later we'll run the Python producer. So say for customer ID 30, and say region is a number from 1 to 8. So that is 5. So I've produced this message. So I should be able to see this message here. So first is the customer location. I go to the messages. And here I see that customer ID 30 and region 5. Next, let me go to the customer enriched. So in customer enriched, we should be able to see all the customer attributes. So here you see, right, gender is female, age is 23, annual income 29, and spending score is 87. The last one is the customer offers. So here you see that we have given an offer saying that buy the new Pepe Pizza using a credit card and get flat rupees 15% off. So this is given to a low income and a high spending category since the age bracket is 23, right? So as per our hypothesis, they use credit card. So that is why we are offering 15% off on credit card. Now let us go ahead and produce another message for another customer and just see what is output. Say for example, 3 and region say 6. So now if you see here, we have this customer who has a low spending score and has a low income. So to low spending score and low income, what we do is we offer membership discount, and also a referral code. So here you see, buy the new Pepe Pizza, get 10% off on membership, and use your referral code. We have a referral code and get 10% off in the next Pepe Pizza order with some validity. Now we will run the Python producer. Here you see the customer location is being generated in real time. So if we go here, we should be able to see all those messages. Right, see here you are seeing this messages. And we told that we are also sending this data to database. Let me just demonstrate that as well. So here you see in customer enriched, here we are getting all this information. All this data is stored here. So coming back to the streaming pipeline. So we saw that how we used Kafka Connect to pull the data from the database to pizza customers, and then Python producer writing to customer location. And we filter out if the customer is in the region of interest or not, and then we join it with that. So in parallel, we write it to customer enriched, and we also write it to table customer enriched. And from there, based on the marketing strategy, we generate the offer discount and write it to customer offers. So this completes the entire pipeline. Thank you.